when we have this extra term here, it makes this a little bit more complicated in that when we isolate the square root, and I can isolate either one, in this case I'm going to isolate 10 minus x, okay, is equal to square root x plus 3 plus 1. Okay, so we could do our inside restrictions. Now there is an outside restriction here, but we're going to kind of avoid the outside restriction because really we're going to rely on our testing this to check this for extraneous solutions. To consider the outside restrictions in this example is a little bit beyond what we need to be doing for grade 11. Okay, so we're not going to, I may ask you what the inside restrictions are here, but we're not going to use the domain to determine extraneous solutions. We're going to just test. So in this case, I'm just going to not do the domain for this problem. Okay, and we're just going to test. Okay, so we want to get rid of the square root by squaring both sides of the equation. Now you cannot square like this, right? Squares are not compatible with pluses and minuses like this. Okay, so we have to make sure that when we square this, we square the whole thing. Okay, now this is something that, this is like a big idea in math, and it's important to understand. So powers and square roots, okay, they are compatible with times and divide. They kind of go together in that we can accommodate times and divide with squares and square roots. Okay, there's an algebra that does that. If we have plus and minus go together with times and divide because we have the distributive property. Okay, so those are compatible algebraically. But when we talk about squares and square roots do not mix or are not compatible with plus and minus. So when I have square here with a plus, I cannot just do square. Okay, like I cannot just distribute that. When I had just squares and times and divide, that's possible. So it's important to understand that this is incompatible. These are not compatible with each other. So we have to be careful, okay, whenever we have squares with plus and minus, like we do in this case here. So when I square this, okay, so I'm going to square the left-hand side first. That will just undo the square root. In this case here, we have to do the FOIL. This is a binomial that we have to square. So we're going to end up with square root x plus 3 squared plus 1 times square root x plus 3. And we're going to have to do x plus 3 times 1. And then we're going to have to do 1 times 1. So first, inside, outside, last. So when I do this, I still have a square root term that I have to deal with. Okay, so what I'm going to do is first of all just collect like terms here. So I get x plus 4 plus 2 square root x plus 3. So I'm going to then isolate this square root. So I'm going to subtract x from both sides. Subtract 4 minus x minus 4 minus x. So this becomes 6 minus 2x is equal to 2 square root x plus 3. I can square, but because remember that times and square roots are okay together. But I'm just going to simplify this by dividing everything by 2. That way I don't have to worry about that times 2 here. And then I get rid of this square root. Okay, so I've had to get rid of 2 square roots. Okay, and then I'm going to FOIL this out. First, outside, inside, last gives me negative 3x, negative 3x. So that makes my negative 6x. And on this side now, we just have x plus 3. Make it equal to 0. Okay, so I've got x squared minus 7x plus 6. This is factorable. I get minus 6 minus 1 equals to 0. So I end up with x equals 6 and x equals positive 1. Now, I didn't actually get a domain, so I'm not sure that these are, I have no clue whether these are extraneous or not. So I'm going to just go back to my simpler test since the domain restriction for this was a little bit complicated. I'm just going to test these back into the equation. So I'm going to test x equals 6. I get square root 4 minus square root 9 equals 1. So I get 2 minus 3 equals positive 1. That's not true. This must be extraneous. Okay, so then I'm going to test x equals 1. So I end up with square root 9 minus square root 4 equals 1. 3 minus 2 equals 1. That's okay. So that's a perfectly good solution. Okay, so the x equals 6 is extraneous, but x equals 1 is our solution. And again, we could graph this, and we can see that this actually will work out on our graph as well.